Okay, we're going to look at the mixed review. And the first 1, 2, 3, 4 problems all are the same thing, where you're looking at vectors and you are finding the horizontal and vertical components and then adding them up and then finding the managing direction. So we're going to do number 26, which is the most difficult. And the best way to do this, first you're going to look at your picture. So if you look at the picture here, you see I have 4 vectors. And what I would do is I would call them different things. I would call them like A, B, C, and D. And this makes it easy because one of the things I showed you was if you put it in tabular form, it makes it so much easier to do this. You also have to be aware of the geographic directions here. We have north, south, east, and west. So before I start, I'm just going to make myself a nice table, because when you do stuff in a table, it makes it more organized. And then you won't make a mistake with putting your answers in. So now I'm going to write my vectors A, B, C, and D. And then I'm also going to do my resultants for those. I'm going to do Rx, and I'm going to do Ry. We're going to use our same standard Cartesian sign convention. Up and to the right is positive. So we're always going to use that sign convention in this class. Okay? There's going to be probably one time in the next chapter when we do friction on an incline, and then we'll just tweak it and adjust it a little. Okay? But in high school physics, we're going to do this almost all the time. All right. So now I'm going to look at each vector individually. So let's start with vector A. If I look at my picture, vector A goes like this, and it's 100 meters. Now, I don't even have to do a calculation here. So I want to find the x and the y component of this. Now, because this is horizontal, it's all x. So because this is all x, AX is equal to 100, and AY is equal to 0. There is no vertical component of vector A. Now I'm going to do vector B. So vector B, if you look at it, vector B goes like this. And I'm not doing it to scale. This is 300, and it goes down. So this has no horizontal component. So BX is equal to 0, and BY is equal to negative 300 meters. Now, C and D are obviously a little bit more complicated. So I'm just drawing to the side. I see that vector C looks like this, and it's 150 meters. But I need to find the horizontal and vertical components. So this is where I start, and this is where I end up. So first I'm going to go this way. I want to go from here to here, but I have to go horizontal and vertical, and the components are perpendicular. So this is going to be CX, and from the head of this vector I do the tail of the other, and this is CY. Now in the picture they told me that this angle here is 30 degrees. Now how do I know? Do I use sine, cosine, or tangent? Well, you don't want to memorize one is sine and cosine, because in the next chapter, and when we do forces, they're not always going to give you the angle from the horizontal. So don't memorize, oh, this one's sine and this one's cosine, because that's bad to do, and you'll end up making mistakes. So the first one I always think of is sine. So I know that sine of theta is equal to opposite over hypotenuse. So now I'm going to look at my picture, and I'm going to say sine of 30 is equal to opposite. Opposite the 30 is CY over the hypotenuse, which is 150. So CY is equal to 150 times sine of 30 degrees. So now what I'm going to do is I'm going to take my calculator, and with the calculators we're going to use on the test, I'm going to press 30 sine times 150 equals, and that comes out to be 75. So this is 75 meters. Now look at my picture. According to my standard Cartesian sign convention, this goes to the left, and the left is negative. So CX is going to be negative 75 meters. So this is negative because it's going to the left and not the right. Remember, standard Cartesian sign convention. Now to do C, oh, this was CY, whoops. So this is, well, it's going down, so that's still, I wrote it in the wrong place. CY is negative 75, whoops. We have to figure out CX. See, I make mistakes too. All right, but when you're looking at it, then obviously I caught my mistake. And the picture helps. All right, now I'm going to do CX. So CX is equal to 150 cosine of 30 degrees, and it's cosine because it's adjacent to the given angle. So then on my calculator, when I do that, that comes out to be 130. So it's going to be 30 cosine times 150 equals 129.9. So I rounded that to 130. Now this again goes to the left, so this is also negative. So CX is negative 130 meters. Now I have one more vector, which is D. So D goes up like this. And now I'm going to find my horizontal. So this is where I start. This is where I end up. So this is going to be dx, and this is going to be dy, and this angle here is 60 degrees. So dx is equal to 200, because this is 200, times the cosine of 60 degrees, and it's cosine because it's adjacent to the given angle, and that comes out to be 100 meters. But because dx goes to the left, this is going to be negative. So when I put this on the chart, dx is equal to negative 100. dy is equal to 200 times sine of 60, and it's sine because it's opposite the given angle. And this comes out to be 173 meters, and this goes up, and up is positive, so this is plus. So dy is equal to plus 173. Now what do I do? Well, I have to add up all my x's and all my y's. So now I'm going to say that Rx is equal to RA plus RB plus RC plus RD. So that's going to be 100 plus 0 plus negative 130 plus negative 100. So Rx comes out to be negative 130. Now I'm going to do the same thing for the y's. Okay? So Ry is equal to AY plus BY plus CY plus DY. So that's equal to 0 plus negative 300 plus negative 75 plus 173. So Ry comes out to be negative 202. Now remember, I'm not finished because I want to find R. So if I have Rx and I have Ry, first I'll draw myself a picture. So Rx is negative, so I'm going to draw it to the left because that's negative. From the head of that one, I do the tail of the other. So Ry is negative, so that goes down. And now my resultant is going to be like this. Now remember, my resultant has to have both magnitude and direction. So this is a right triangle, so to find R is equal to the square root of Rx squared plus Ry squared, which is the square root of negative 130 squared plus negative 202 squared. So R is equal to 240. But I still need to find the direction. So I have opposite, and I have adjacent, and I know opposite over adjacent is tangent. So I'll do this over here. Tan of theta is opposite over adjacent. So opposite is ry over adjacent, which is rx. So it's going to be 202 over 130. So on my calculator, I go 202 divided by 130, and that comes out to be 1.55. But that's tan of theta. So now I press second tan, and my angle comes out to be 57.2 degrees. So then my final answer is going to be 240 meters at 57.2 degrees. Now this angle here, I'm measuring from here over, and that angle is south of west. Now, if you try to do shortcuts when you do this, you just make a mistake. Obviously, you see I did 5 pictures. I drew each vector individually, and then I did my resultant vector, and if I do it step by step by step like this, I'm less likely to make a mistake. Remember, most people are visual, and this helps you to visualize it. The most important thing in this, I think, is the table. Because if you do the table and you're careful with your sign convention, you're not going to make a mistake. So it's also important to do the table.